Hello dear students, let's solve this sum from our equilibrium chapter. So you can see the sum here. They have given sulfur dioxide reacting with oxygen to form sulfur dioxide. Okay, I will just explain this sum. Before that I will give you my email ID. So if you are interested in any of my online or offline class, you can contact me. This is my email ID. You can drop an email here at class@mumbaiedutech.in. So it is especially for IGCSE and IBDP from class 9 to 12. So if you are interested, you can drop me a mail. Okay, so let's go back to the question. They have given this question, and first they have asked write the equilibrium constant. So for this, as I have explained in my previous videos also. So here first what you have to write Kc, that is equilibrium constant expression is denoted by Kc, equals to, we have to write the product in the numerator. The product is sulfur trioxide. So you will write SO3, okay, and then in a square bracket, okay, and also this 2, whatever this coefficient written before, this stoichiometric coefficient 2 is written, that will become indice, that will come here on the top here. So this 2 has come here on the top. Now upon, now this we will write the, in the denominator we will write the reactants. These two reactants are there, SO2. So first we will write SO2 in a square bracket, and before SO2 the 2 is written, you can see coefficient 2. So this 2 will come here as the indice, and then second reactant is O2. So O2 also we will write here in the denominator, and before O2 nothing is written, so here indice nothing will come. So this is the way how you can write equilibrium constant expression for the reaction. So let's see the second question. Second part of the question, they have asked, consider the following reaction in contact process. So B part, state the catalyst used in this reaction. So this you must have studied when you were in our when you were in 10th. That time there was contact process. This sulfur gas they used to take out using bubbling it, okay, and putting water at high pressure. Then this sulfur dioxide was there. Then what they were doing in order to make sulfuric acid, then oleum was being made, and for that contact process we were using our vanadium 5 oxide. This was our catalyst used for this. So vanadium 5 oxide, or it is also called as vanadium pentaoxide. So we can write V2O5. So catalyst uses V2O5. Now the B part, second of the B part, state the effect of catalyst on the value of the equilibrium constant. So always remember, catalyst here, catalyst is not, no, catalysts are there, they doesn't play any role in actually increasing this or decreasing the product or increasing the product, because what it does, it just provide more kinetic energy. So more kinetic energy will be provided to the both sides, even to the product side and even to the reactant side. So both will give equal amount of kinetic energy. So there will be no change in the equilibrium constant. So equilibrium constant will not shift, and it doesn't actually, neither it helps in shifting the equilibrium to left or right. So that is the main thing you should remember. In kinetics, before that previous chapter was there, in that it helps, it actually reduces the activation energy. So more particles will be there, for which will have more kinetic energy, okay. That is the main thing. So in this way you should remember, okay. Let's see the C part of this question. C part, they have asked, use the collision theory to explain why increasing the temperature increases the rate of reaction between sulfur dioxide and oxygen. So for this I will make a container to explain you. So here I will make sulfur dioxide here. This is sulfur dioxide, black colored molecule is sulfur dioxide, okay, and I will put blue colored molecule as our oxygen molecule. So I will make here 2-3 sulfur dioxides and 2-3 oxygen molecules, okay. So in this sulfur dioxide and our oxygen molecules are there, but they are moving very slowly because we haven't increased the temperature. Now as soon as we increase the temperature of this container, so what will happen? So we will put a Bunsen burner here and increase the temperature. So these molecules are there, they will start moving fast. Okay, they will gain kinetic energy, so it will move very fast here. It will start moving, this also will start moving in random direction, this also will start moving, and this also will start moving. So there are chances of collision will be more because they are moving very fast. All of them will start moving. Okay, so but with in a fast, when they are moving very fast, like on the highway, there are chances that you will find lots of means you will find that accidents happen mostly in the highway because cars are running at a very high speed. So when something is moving at a high speed, that chances of collision will be more. So here they will dash against this sulfur dioxide molecule will dash against oxygen molecule, and the reaction will take place to form sulfur trioxide. So that's why you should remember here, the main thing is that increasing the temperature increases the kinetic energy, so they will move more faster, and the chances of collision will be more. So successful collision will take place. There are two types of collision. Now, initially when temperature was not increased, then that collision was there between sulfur dioxide. I will draw and show you. The collision was like this. This is our sulfur, okay, sulfur dioxide, and this is our oxygen molecule, blue one. So they may collide or they may not collide. If they may collide, then that collision will be just like touching each other and not happening at all. So this oxygen molecule come here, and then what will happen? Now this oxygen molecule will just touch it. Okay, no reaction happening between them. So this is called as glancing blow, and geometry is also not proper. Now I will show the same example here. So we will take our sulfur dioxide here. This is our sulfur dioxide, SO2, here in this diagram, and this we have done, so I will cut it. And now this our oxygen, so this is our oxygen molecule, okay, O2. So now what will happen here? Now correct geometry is also happening, so this two will come here, and now you have heated up also, so they will do what now? They will come together, and these three will combine to form sulfur trioxide, because now head-on collision will happen. This is called as head-on collision. Wherever head-on collision is happening with proper geometry, so this reaction will take place. So that's why increasing the temperature increases the rate of the reaction, means more of the particles, more of the molecules will collide to form a head-on collision, and successful collision will take place, and because of that product will be formed. So these two will collide to form sulfur trioxide molecule. So you can see sulfur trioxide is formed. This one and this one has collided in a proper way, and this sulfur trioxide molecule is formed. So that is the way what it is the effect of increasing the temperature. Okay, so now let's do the next part of the question. Here next part of the question, they have asked, using Le-Chatelier principle, state and explain the effect of position of equilibrium. What is the main thing you should remember here now? First we will do for pressure. So whenever pressure is asked, so always for pressure now you need to count the number of molecules. So on both the sides, reactant side and product side. So here on the product side, here you can see 2SO3 is there. So there are 2 molecules. Okay, just see the coefficient here. Now on the reactant side, which I will show with green color. So here 2SO2 is there, 2SO2, and then one O2 is also there. So plus 1. So there are 3, that means 3. So 3 molecules are there in the reactant side. So 3 versus 2. So you have to actually see which one is the least. So as 2 is the least, okay, 2 is the least. So you have to see the least one. So always the side which is having the least molecule, the pressure will favor that side. Okay, so now here 2 molecules are towards our sulfur trioxide. So increasing the pressure will actually produce more of the sulfur trioxide. So sulfur trioxide produced will be more because it contains our least molecule. So you got it in this way. And now we will do the second part, removing the sulfur trioxide. So what happens if you remove the sulfur trioxide? Then what you have to do, actually you have to see whether it is reactant or product. If it is product, like here sulfur trioxide is a product. So if you are removing sulfur trioxide, so what will be there now? These reactants are there, they will combine to form more sulfur trioxide. So more of the sulfur trioxide will be formed, and equilibrium will shift towards the arrow will, this right side arrow will work now. Left side arrow will not work, means more of the sulfur trioxide will be formed. Now actually what will happen when you are removing it means there will be loss on the product side. So more product will be formed to compensate that loss. But I will also tell you, if you are removing the reactant, what happens? Suppose if you remove like sulfur dioxide or oxygen, so you are removing the reactant means what will happen now? The product form will be less because reactant is less. Okay. And if you are supplying reactant instead of removing it, suppose you are supplying reactant. So like if you are supplying reactants here, this more, sulfur dioxide more, okay, or oxygen more. So what will happen? Now reactants are more, so more product will be formed. So this you should remember. And now we will do the third part of D, that is using catalyst. So that we have done previously also. Using catalyst, the main thing is that it just increases the rate of the reaction by increasing the kinetic energy. So kinetic energy will be there with more activation energy. Kinetic energy of the particle will be greater than that of the activation energy. So it will just increase the rate of the reaction, but equilibrium will not shift towards the right side or to the left side, because it will favor both the sides. Even product side also, like sulfur trioxide will also gain the same amount of kinetic energy as the reactants like sulfur dioxide and oxygen. So effect of catalyst, there will be no effect at all in the shifting of the equilibrium, okay, or position of equilibrium, or even increasing the equilibrium or reducing the equilibrium constant expression. So there will be no effect at all. So this you should remember. So thanks for watching my video. So in case here you can again note down my email ID if you are interested. So class@mumbai edutech.in. Thank you for watching. Take care. Bye.